All right, we're starting on 1.3, fractions and mixed numbers. So in this section, basically doing a lot of different stuff with fractions as far as multiplying, dividing, adding, subtracting. So they start with, I know not everybody's a big fan of fractions, so we're going to get them out of the way right from the start. So what I'm going to do with these videos is just kind of examples that you're going to see on your homework assignment. We also have a PowerPoint that accompanies each section, so I would recommend, if you haven't done so, that you start with the PowerPoint and go through the PowerPoint and then come to the videos to kind of reinforce what you would see on the PowerPoint. All right, so the rule basically when you are multiplying fractions are you multiply straight across your denominators and your numerators. You just multiply top times top and bottom times bottom. Sometimes you want to look to see if I can reduce something first to make it easier when I submit my answer, because all answers must be in what we call the lowest terms. So if I can cancel or simplify something out first, I would do that first, and I have some examples of that coming up. But in this problem, nothing cancels out. So 3 and 7, there's not a number that goes in both 3 and 7, and 2 and 5 as well. So all you're really going to do is multiply straight across. So 2 times 3 will give me 6. And then I go 7 times 5, and that gives me 35. The last thing I want to do before I submit my answer is look to see can I reduce this any further? Is there a number that goes into both 6 and 35? And there isn't. So that would be in its lowest terms as it is. One thing you're always going to know is if you have a even number, which 6 is an even number, but 35 is an odd. Anytime you have an even over an even, you must reduce that further, okay? Because at the very least, 2 will go into both of those if you have an even over an even. So you're going to hear me say that a lot. Don't ever leave an answer with 2 even numbers, with an even number in the numerator and an even number in the denominator. Keep dividing each of those by 2 till you get it to this lowest terms. All right, our next problem is we're actually dividing. And division is similar to multiplication in the sense of the rule is we don't change the first fraction. We leave the first fraction the way it is. So we're not going to mess around with the 1/2. You're going to change your division sign to multiplication. And then you're going to do the reciprocal of the fraction after the division sign. And what reciprocal means is you're going to flip your numerator and your denominator. So in other words, 7 over 10 is going to turn into 10 over 7. And now we're just multiplying. So now it comes back to what we did on number 1. Change the division to multiplication and flip the following fraction. Now what I told you before, that can kind of give you a shortcut as far as simplifying your answers, are you have the 2 and the 10. So see how 2 goes into both 2 and 10? All right, so if you recognize that, you can change that to 1 over 5. But if you don't recognize it, you're just going to have to simplify your answer. So I'm going to kind of show you both ways. So let's say I don't see that 2 goes into 10. 2 will go into 2 and 2 will go into 10. I'm just going to multiply straight across. So I'm going to go 1 times 10 and 2 times 7. So 1 times 10 is 10. 2 times 7 is 14. So again, this is what I'm talking about. I cannot submit this answer the way it is because it is not simplified. This is an even number and this is an even number. So at the very least, 2 will go into both of these numbers. So I must simplify it first. So I got to divide 2 into both of those numerator and denominators, which will give me my answer of 5 over 7. What I was talking about, let's go back to this, the way it was set up here. If I recognize that 2 will go into 10, I could just change this to 1 and this to 5, because 2 will go into 2 one time and 2 will go into 10 5 times. If I recognize that, I then multiply straight across. 1 times 5 is 5, and 1 times 7 is 7. So however you get to the 5 over 7, the most important part is that you get to 5 over 7. So if we don't recognize that 2 will go into 10 and we come here, then we've got to just reduce it here. If I do recognize it, I can do that first. All right. Next problem is similar, but we are multiplying. So this is the type of problem you definitely want to simplify first. Because if I just multiply 11 times 13, I'm going to get a pretty big number. Then I'm going to get another really big number, 39 times 22. So that's going to require me to do a lot of reducing to get before I could submit that answer. But what I want you to recognize is that 11 and 22 are both multiples, and 13 and 39 are as well. So in other words, 11 will go into both of these numbers. 11 goes into 11 one time. 11 will go into 22 two times. Now 13 is a little bit different, but actually 13 times 3 is 39. So 13 goes into both of these. 13 goes into 13 one time. 13 will go into 39 3 times. So the fact that now I've simplified it makes my life a lot easier. I'm just going 1 times 1 to get 1, and then 3 times 2 here, and that's going to give me 6. All right, so we talked about how to multiply and how to divide fractions. So now we are getting to addition and subtraction. The first thing you must always keep in mind is when you are adding or subtracting fractions, your denominators have to be the same before you do that. So in this case, they are the same, and we're going to talk about when they're not the same, what you have to do. But in this case, they are the same. Then what you do is you just keep the denominator. You don't subtract 3 from 3. We keep the denominator. And really all you're doing is subtracting your numerator, your top part of the fraction. So what is 2 take away 1? That would give me 1 on top, and I just keep the denominator of 3 because my denominators were already the same. So that's pretty much all you do. If the denominators are the same, it's really not that hard. It is when they're different, requires a little bit more work. So let's look at another example of that real quick. We got 27 over 35. So again, what you'll notice is my denominators are the same here. So if they're the same, I keep that denominator. And again, all I'm doing is subtracting my numerator. So 27 minus 22 would give me 5. And again, we can't submit the way that if this answer is, if we submit it, it'll be incorrect because it is not reduced. What you have to recognize is that 5 goes into both 5 and 35. So really what you're doing when we're simplifying it is you're dividing both your numerator and your denominator by that 5. So 5 divided by 5 gives me 1. And then 35 divided by 5 would give me 7. So that is your reduced answer to that problem. So now what we're going to see is, I want you to look at number 6. And the way it's going to be presented to you in My Math Lab, it's kind of vertically. I will not solve, or I don't solve my fractions that do not have the same denominator vertically. I ended up writing it, I'll write it vertically. You'll see me writing it like this. Okay. And what you have to do on these problems is called coming up with a common denominator. Okay. And I'm looking at the 7 and the 9, and I'm looking for the smallest number. We call it our lowest common denominator, or LCD, of 7 and 9. And the way I like to do it is I always say, look at the biggest number, okay? And in this case, the biggest number is 9. And I'm going to start with the multiples of 9. And I'm going to say, okay, well, will 7 go into 18? No. So go to my next one. Will 7 go into 27? It has to go into it perfectly. And again, no. So I keep going. 36, no. 45, no. 54, no. Until I get to 63, okay? And in this case, the lowest common denominator was just 9 times 7, all right? But sometimes there'll be a number smaller. So you always gotta just, and again, you'll do a lot of this in your head. But if you need to write them out, write them out. But in this case, smallest number that 9 and 7 will go into is 63. So that is what I'm going to use as my denominator. And so what you'll see me do is I just put it, it's going to be in both of these spots, and it's also going to be in my answer. So before I do anything else, I just write 63, 3 different places. The next question, I always kind of start with the bottom fraction and then work my way up for whatever reason, but what do I have to multiply 9 to in order for it to be 63? And the answer in this case is 7. I got to take 9 and multiply it by 7. And I'll do that same thing to my top part of the fraction. Whatever I do to the bottom, I have to do to the top as well. So I go, oh, my red pen is not working right now, so I'll have to fix that in a second. I'm going to multiply the top and bottom by 7. So 9 times 7 gets me to 63. 7 times 7 will give me 49. So basically what I did is I changed 7 over 9 to 49 over 63. Technically, this is still 7 over 9, but it's written with a denominator of 63. I'm going to do the same thing up top. So I need to get everything with that same common denominator. So what do I have to multiply by 7 to get to 63? In this case, it's 9. So I'm multiplying 9 to both my top and the bottom. 7 times 9 gives me 63, and 2 times 9 would give me 18. So again, I keep my denominator of 63, and all I'm doing now is adding 18 to 49. 9 plus 8 is 17. 4 and 1 is 5, plus the 1 that I carried. So I'm going to end up getting 67 over 63. Now, I will just enter my answer as 67 over 63. You do not have to change that into a mixed number. It'll accept 67 over 63. The only thing you just got to make sure is, can I reduce 67 over 63? In this case, the answer is no. So it'll accept that. And if you're not sure, really, you get 3 chances on each answer. So if you wanted to just put it in to see if it's reduced, but usually if you get it wrong and you know you're pretty solid with your work, it's probably because you didn't reduce it correctly. So again, it'll take the 67 over 63. All right, let's do another example. And again, I'm going to start just writing these vertically. Like I said, when you see them on the MyMathLab, it won't necessarily come out that way. All right, so I got 2 denominators. You'll notice the 8 and 20. They are not the same. So I need to come up with a common denominator. And what, again, like I said, I'm going to start with the bigger number. In this case, the 20. I'm just going to kind of write the factors up here. It goes 20. 8 doesn't go into 20. Sometimes it'll go into that first number, and then we're just going to use that. But in this case, it doesn't. The next multiple of 20 would be 40, right? And hopefully you recognize that 8 will go into 40. 8 times 5 would give me 40. So I'm going to use 40 as my LCD. And again, I just start out writing it all 3 places. Start with the bottom one. And again, oh guys, just keep in mind, this one we were subtracting, this one we're adding. So it doesn't, the only time it really comes into it is that last step. I'm going to subtract this number from this number. Okay, but again, 20 times what gives me 40? The answer is 2. So we're multiplying 2 to both places. What's 11 times 2? It gives me 22. Then I come to the top one here. Again, I'm rewriting 11 over 20. It's 22 over 40. 5 over 8, 8 times what gets me 40? The answer is 8 times 5. So I do that 2 spots. 5 times 5 gives me 25. So again, be careful. In this one, we're subtracting. So I'm subtracting 25 from 22, and that'll give me 3. And again, my last question is, can I simplify 3 over 40? And basically, there's not a lot of multiples of 3. Basically, the only way I'd be able to reduce that is if 3 would go into 40. And the answer to that is no, I cannot simplify that any further. All right, going on to our next example. Now we're going to start dealing with mixed numbers. So what you have is 4 1/4 times 3 2/3. Now, when you are multiplying these, we cannot multiply these as mixed numbers. So we have to rewrite them in what we call improper fractions. And the way you do that is you take your denominator, so in this case 4, you're going to multiply it by the whole number out in front. So in other words, you're going 4 times 4, which would give me 16. And then whatever that gives you, you're going to add it to the number of the numerator. So 4 times 4 gives me 16, and then I'm going to go 16 plus 1. So that is going to give me 17. Okay, and then you keep whatever your denominator was, that stays as your denominator. Okay, so in other words, even before I do this, when my denominator stays the same, it's still going to be 3. Okay, but what I do is I multiply 3 times 3, which would give me 9. And then I go 9 plus 2. And 9 plus 2 would give me 11. So I rewrote both of these mixed numbers as what we call improper fractions. And then all I'm going to do in this case now is just multiply straight across. And ideally, we'd be able to simplify this a little bit further, but we're not able to because 4 won't go into 11 and 3 won't go into 17. So you're multiplying straight across, so 4 times 3 is the easier one, but 17 times 11 is probably where you want to use the calculator. And you get 187. Now, what you want to do is kind of look to see is there a number that will go into both 187 and 12? And in this case, all I did was I said, well, I got 3 chances. I'm going to enter that in to the program and see if I get it wrong, then I probably know I have to reduce that. But it actually took it that first time. So that's basically let me know that I can't reduce that any further. All right. So that's how you do it when you're multiplying. You change them and then you multiply. So what are we going to do when we're dividing and we have these improper fractions? And we'll look at that. So same thing, we got 2 mixed numbers that we got to convert to improper fractions. So we can start out, and we're going to leave it as it is right now. We're going to leave it as division. Okay, we'll address the division sign after we convert these. Okay, but again, to convert it, it's 4 times 2. Okay, and then add the 1. So 4 times 2 gives me 8. Add 1 to it gives me 9. So 2 1/4 converts to 9 over 4. Same thing here, 12 times 1 is 12. Add 5 to 12, and that gives you 17. So now we've just rewritten this division as 9 over 4 divided by 17 over 12. So again, the rule when you're dividing fractions is you keep that first one, 9 over 4, change division to multiplication, and then you do the reciprocal. You got to flip these around. We get 12 over 17. What hopefully you recognize here is this 4 and 12, right? That there's 4 will go into both of those. 4 goes into 4 one time, and 4 will go into 12 3 times. Now we just multiply straight across. 9 times 3 is 27. 1 times 17 is 17. Ask yourself, can I reduce that? Is there a number that goes into 27 and 17? The answer is no. One thing we haven't really talked about yet is what are prime numbers. Prime numbers basically mean they're the only number that goes into it. The only way you can multiply and get those numbers are 1 times 17. So in this case, no, we cannot simplify that problem there. So what are we doing? We're adding these mixed numbers. Again, I'm going to write these because what you're going to see on this problem is our denominators are different again. So anytime my denominators are different, I'm going to write it vertically. Okay. What I'd recommend in a problem like this is just to ignore the mixed numbers out in front for right now. And then let's just address this as 3 over 7 being added to 3 over 5. And I have to come up with my LCD. I need to come up with my lowest common denominator of 7 and 5. So if you're thinking about the multiples of 7, in this case, the only way we're going to get there is to multiply the two together. So you think the multiples of 7, and we could go through them real quick up here, 7, 14, 21, 28. So 5 won't go into any of those. Remember, 5 will only go into a number that has a 0 or a 5 in it. All right, so how do I get to 35? With the bottom part, I got to multiply top and bottom by 7. It's going to give me 21 over 35. And then on this one, I got to multiply top and bottom by 5. So this is what it looks like here. We could add these together. 5 plus 1 is 6. And 1 plus 2 gives me 36 over 35. Now this time I'm going to bring in these mixed numbers. We're going to add these together now. 13 plus 53. And I'm going to end up getting 66. Now I'm not a huge fan of this problem because I cannot enter this the way it is. Okay, because 36 over 35, and let's kind of do this off to the side. This is when we're working backwards. So we have an improper fraction, and we need to change this to a mixed number. So the way you do that is it's like you're dividing 35 into, how many times will 35 go into 36? It'll go into it 1 time. And you got to think of 36 minus 35. What's going to be left over when I do that? I'm going to be left with the 1. So what you're doing is you're converting this mixed number to 1 over 35. Okay, again, 35 goes into 36 1 time. Okay, and if you subtract 36 from 35, you get 1 left over, so we've got to put that on top, and then you keep it as 35. All right, so that's how I got to convert this. Well, I already have 66 there. So what do I have to do with this 1? If I already have 66, I'm going to have to add the 1 to it, and that's going to make this 67. So 67, 1 over 35. Not a very pretty question. Not a big fan of it. But if you get something like this, it'll not accept it because we have to convert that mixed number. Normally it'll take that mixed number. The reason why it doesn't is because there's a number in front of it. So just keep that in mind. If you do get one of those, that is what you'll have to do there. All right, a similar problem to the one we just did. The only difference is in this one we're subtracting. So again, these mixed numbers, these numbers out in front, we're not going to deal with until really the end. So you're almost like you're ignoring it to start out with. We got to come up. We notice our denominators are different, so we got to come up with the common denominator. Remember, I said you always start with that bigger number, and in this case, that is the lowest common denominator because 6 will go into 12. So we're going to use 12 as our denominator for this problem. And how do I get 6 to 12? I got to multiply the top and bottom by 2. So 5 times 2 gives me 10. Again, I'm not changing this problem here, so I'm just going to keep it 11 over 12. Or in other words, if it makes you feel better, you can say, well, I got to multiply by 1, multiply by 1. It's not changing that column. It's still going to just be 11 over 12. At this point now, I move these over, the 9 and the 4 that were there. Remember, you're subtracting. That's the key. Don't start adding on these. You got to subtract. 11 take away 10 gives me 1. 9 take away 4 gives me 5. So this problem's done. I know in the other problem, we'd have to keep going. And that was because, remember, we had a bigger number in our numerator than our denominator. And we had a number out in front. Normally, you could just enter that the way it is. And this one, it's already kind of simplified for us. So we are done with that problem there. A couple more in 1.3. And what I try to do is do at least one example of every problem that you may see. So in this case, hopefully you recognize right away that you have the same numbers there and there, which basically means you can change those both to 1 because 4 goes into 4 one time and 4 goes into 4 one time as well there. And then we multiply straight across. 11 times 1 is 11. 1 times 13 is 13. You may see this, and hopefully we don't overthink that. You're taking a whole number, you're adding it to 8 over 9, and what you're going to get is just 1 and 8 over 9. And that's not 18, that's 1 and then 8 over 9. Got one more for 1.3. All right, so what you notice here is we have 3 fractions. All 3 fractions have different denominators, right? So I'm going to write this vertically. And where I was normally finding my LCD for 2 denominators, I have to find my LCD for 3 denominators. So in other words, I got 5, 15, and 10. But again, I do it the same way. I'm going to start, what's the biggest number of 5, 15, and 10? The answer is 15. So I'm going to start with 15. Well, 5 goes into 15, and 15 goes into 15, but 10 won't go into 15. So I can't use that. The next multiple of 15 is 30. Well, 5 will go into 30. 15 obviously goes into the 30, and 10 will go into 30. So that is going to be my lowest common denominator, my LCD. So I'm going to use 30. And again, I write it in my answer as well because I am going to use 30 is going to be my denominator in my answer as well. So I got to do it 3 different spots. 10 times what gives me 30? And that is 10 times 3. So 7, and I use the same number. 7 times 3 gives me 21. 15 times what gives me 30? That's times 2. 11 times 2 gives me 22. Right now, we're not worrying so much about these signs. We'll talk about that in a second, but we just got to change all these fractions with the denominator of 30. 5 times what gives me 30? It'll be 5 times 6. So I do 6 times both top and the bottom. 4 times 6 gives me 24. Hopefully you understand, guys, what we're doing here. We're not, these fractions, they look different, but they really are still the same. Because 24 over 30 reduces to 4 over 5. 22 over 30 reduces to 11 over 15. 21 over 30 will reduce to 7 over 10. So I'm just fractions really haven't changed. Just the way they appear now are a little bit different. And they're all with a denominator of 30. So now I can add and subtract them. And again, what I'm doing here is I'm basically doing this. 24, take away 22, and then adding 21. So what's 24? Take away 22. That'll give me 2. And then I go 2 plus 21. 2 plus 21 is 23. And then the only thing I would say is just check to see, can I reduce 23 over 30? Is there a number that will go into both 23 and 30? And the answer is there is not. So those are some of the type of problems that you're going to see. I try to do, like I said, an example of every type of problem you'll see, but I may not hit on every single one of them. But it will kind of get you started on what you need to do with 1.3.